Hi there. All right, hopefully you have watched the first video and maybe practiced some of the homework problems dealing with finding the area of an equilateral triangle. We are now going to look at finding the area of a square, which is a regular polygon for a quadrilateral. Now, if I knew the length of this square, obviously I would not do anything that I'm going to be showing here. I would just do, right, this length times the same length because it's a square, right? Base times height. But if I didn't have that, let's say I had some other part to this problem, I'm going to want to use the strategy that I'm going to be using here. All right, so just like when we talked about equilateral triangles, I can think of this square as being inscribed, meaning it's inside, okay, of that circle. And this would be the center. And because it's inscribed in the circle with its vertices on the circle, I could go ahead and draw each of those radii. That's the plural form for a radius in a circle. And each of those is going to be the same length. Okay. And let's say in this problem I am given that that radii is, let's say it's 8. Okay. So the radii is 8, that means this is 8, all of those is going to be 8. First thing I'm going to do is I'm noticing that that square, just like the triangle we had, the triangle got broken up into 3 smaller triangles, okay? This square is now getting broken up into 4 smaller triangles. So I'm going to find the area of one of these triangles, just like I did in that last problem, but instead of timesing it by 3, I'm going to times it by 4 because there are 4 of them. So I'm going to write my area is going to be 4 times the base times height divided by 2. That's what I'm going to use to find the area for that square. All right, so I don't know the base and I don't have the height. So I'm going to drop, first of all, before I do that, let me find out what would be this central angle. There's 4 of them. All together they're adding to 360. 360 divided by 4 is 90. So that's a 90-degree angle. That's a 90-degree angle. I know I could put the little box there too, but that's 90, that's 90, that's 90, that's 90. So my apothem, also known as the height of this one triangle, is going to drop down and it's going to divide that 90 into 2 equal pieces. So this is going to become 45 degrees and that's going to be 45 degrees. Okay, same process. We're going to be doing this same process many times with different types of polygons. Same process we did with the equilateral triangle. All right, so that means this is 45, this is 90, that means this is 45. So it looks like, again, there come those special right triangles. They're going to keep coming up. So I have a 45, 45, 90 right triangle. This is the hypotenuse in this right triangle. It's 8. That means this must be 8 divided by square root 2. Okay. This is 8 divided by square root 2, which means this is also 8 divided by square root 2, which means this piece right here is also 8 divided by square root 2. Kind of complicated, but that's okay. I'm going to leave it like that for right now. So again, I want the base times the height. So my base is going to be this length right here, because again, I'm finding the area of that triangle that's shaded in red. So how do I find that? That's going to be 8 divided by root 2 plus 8 over root 2. I add 2 fractions. The denominator stays the same. That's going to be 16 over square root 2. So that is my base. What is the height? That is right here. That is 8 divided by root 2. So I'm going to go back and put those into my formula. I'm going to write area equals 4 times my base, which is 16 over root 2, times the height, which is 8 over root 2, and that whole thing is still being divided by a2. Now I know some of you, a little bit mathematical savvy, right? You might have simplified up here first, okay? I'm going to still do that. Okay, so what am I going to do now? I'm going to first multiply these two together. So I'm going to have area is 4 times. So 16 times 8, I don't know that one off the top of my head. 128. I know Timmy would have gotten that way before me. Okay. All right, so that's 128. Root 2 times root 2 is a root 4, which is a 2. So I have 128 divided by 2, but that's still being divided by 2. I know, crazy. That's a complex fraction. All right? Okay, let me continue. Again, order of operations says do what's on top first. So 2 goes into 128 64 times. So I'm now going to have 4 times 64 over 2. Now I can continue. 64 divided by 2. 64 divided by 2. What is it? That's 32, right? So I've got 32 times 4. 32 times 4 is back to 128. Yes, so my area is 128. All right. Now, keep in mind, there was other steps I could have done first. Somebody else might have looked at this and said, well, 2 goes into 4. I could cross cancel these first and just have 2, and then end up timesing it by the 64, okay? But that's how I'm going to get to my area. Now, how else could I do this problem? If you wanted to, once you found the base, which was 16 over root 2, we could have just said, okay, well then it's going to be base times the other side, which is also 16 over root 2, and I would get to that same problem, okay? Or I shouldn't say the same problem, I get to that same answer. All right, let's look at one more of these. Okay, and the joy about having these on a recording is you can go back. If you have a question while you're doing the homework and it's looking similar to this, go back and re-watch this and do the steps with that other problem. Okay, so let's say again I have a square, and the previous problem we were given the radius. Let's say I'm not given the radius. Let's say I'm just given the apothem. I'm given that this length, and I'm going to go ahead and call it 5. That's all I'm given. And I need to find the area of this square. Well, I'm going to go back through the same process. I'm going to first go ahead and draw all of the radii. So that's drawing them to their vertice points. Okay, so each one of those is the same. I'm going to then put in what is the central angle. That's 90 degrees. We already found that in the previous problem. So that's 90, that's 90, that's 90. And that apothem cuts it into 2 equal parts, which makes this 45 degrees, 45 degrees. 45, 90, that has to be 45. Okay, so if this piece is 5, this is a 45, 45, 90. These two have to be the same. So that's 5, which makes this 5. Okay, makes the radius 5 times root 2, but I don't need that piece for this problem. Now that I have that this is 5, that means this side over here is 5. Because same thing, this is the same congruent triangle. So my base, just like in the previous problem, we're going to add those. Previous problem we had 8 over root 2, right? So we added an 8 over root 2 plus an 8 over root 2. This is simpler. We got 10. So from this point right now, I could just go, oh, well, it must be 10 times 10. It must be 100, okay? But if I use the other technique, I'm going to have to find the area for 4 triangles. So my area is going to be 4, that's for the 4 triangles. The base is 10 times the height, which is 5. So 10 times 5 divided by 2. If I simplify, that's 50 divided by 2 is 25. 4 times 25 is 100. Okay, so I'm still getting the same answer. Now I know there's going to be some of you going, why would she do that? That's more work. It is more work, but I am showing it to you because as we start to get bigger and bigger size polygons, okay, I'm not going to just be able to do 10 times 10 when it's a different type of polygon, okay? So keep in mind there's more than one way to do these problems, and I know that that's great for some of you. Some of you it might confuse you, okay? So think about maybe sticking to the breaking these up into the triangles and using that process. All right. Come to the Zoom meetings this week. I miss you guys. Okay, bye. One more video after this.